Recording started. Please start the session 2, sir.
Okay, welcome, sir. Good evening to all.
Good evening, sir.
Yeah, good evening, sir.
Good evening, sir.
Good evening, sir.
Oh, okay. Now, Atal sponsors 6 days online faculty development program in the title of Next Generation Green Energy Powered Electric Vehicle and Renewable Energy Integration using Solar Microgrids. Successfully, we completed session 1. Now, we are in the session 2 in the title of Green Hydrogen Energy Technology for EV Applications. Our expert talk, Dr. Chandrasekhar Obbu, Professor, Electrical Engineering Departments, NIT, Delhi. Now, our HOD Rambabu Garu, you just give the
Yes. Yeah. Good evening, everyone. We are honored welcome you all the respected participants from the various colleges in India to the Atal Online Faculty Development Program. Myself, Rambabu Yerra, Associate Professor and Head of the AAA Department from Holy Mary Institute of Technology and Science. So we are very thankful to you all joined for this faculty development program. We are very much thankful. Our department professors, they are encouraging us to learn new trends in technology. And also, I'm thankful to all the respected participants for this session of 6 days FDP program. You are encouraging a lot to learn new trends in technology. So we are warm welcome to all of you once again. Our speaker, very very good evening, sir. Please carry your speech
one
towards
minute, sir. Oh,
sir.
1 minute, sir. Before handing over the session, now just
Yes, sir.
I read out the biodata of our professors.
Yes, sir.
Dr.
Yes,
Chandrasekhar Obbu, sir is
sir.
working as a professor in Electrical Engineering Department, National Institute of Technology, Delhi. Sir has completed BTech in JNTU Hyderabad, MTech in JNTU Hyderabad, as well as PhD also JNTU Hyderabad. Sir, under the supervision, Sir completed 5 members and 2 ongoing persons will be going on the PhD scholarship. Sir achieved as a reviewer for IET Power Electronics and reviewer for DST SERP projects, reviewer for Taylor and Francis, and reviewer for electrical power and systems elsewhere. And Sir also completed the project of development and performance evaluation of control techniques for multi-point clamped inverter fed direct torque control induction motor under DST SERB. On one more ongoing project also going on as a principal investigator, design and development of switched reluctance motor drive for plug-in hybrid electric vehicles with voltage boosting and onboard charging capabilities under DST SERB CRG Core Research Grants, Government of India, under the worth of 55 lakhs and 69,905 rupees. Now, I will hand over the sessions to our expert talk. Sir, please. Chandrasekhar, sir. Hello, sir. Sir, Professor sir, Soganesan sir. Sir is telling it will be muted.
Yes, sir. Yes, sir. Mute, huh?
Chandrasekhar sir, it will be muted. Please unmute it. Sir.
Okay, okay. I'm checking that. No, no, sir. Unmute only.
Sir, Chandrasekhar sir, please check your site, sir.
We don't have the control over that. Given the public, so they can. Now, please check. Saravanan sir, can able to unmute? Two minutes, sir. Sir will join.
Sir,
Yes, sir. Sir joined.
sir, இல்ல அவரு ஜாயின் ஆயிட்டு அவர் கேட்குறாரு அவரோட ப்ரொஃபைல் தெரியுதான்னு கேட்குறாரு.
No, no. They had to share the screen actually. Present now, one button is there. In that one, they had to click.
இந்த
Present
ஒரே
now.
நிமிஷம்.
1 minute.
Sir Chandrasekhar sir, please unmute it, sir. Video only, no audio, please.
Yeah.
Yes.
Can it okay now?
Now,
Yes,
now
sir.
okay, sir. Now okay, sir. Please.
Yeah. Okay. You can see my topic is today green hydrogen energy technologies for EV application. And you see now the EV application, almost all government of India and other countries also, the many researchers and industries, everybody is working on EV, how to propel the EV, and this is also upcoming burden for all researchers to work on this particular area. Earlier, people are working on sustainable renewable energy sources, but now from 2023 onwards, the Ministry of New Renewable Energy Sources, MNRE, is also started the thing, the green hydrogen technology, the green hydrogen, that is H2 technology. So, how to propel the electric vehicle by using green hydrogen technologies. So, let's start today with this. The India climate related commitments. The government of India has already made a commitment based on the Indian climates. So it is what are these commitments is the India will reach its non-fossil energy capacity to 500 gigawatts by 2030 to meet 50% of its energy requirement, that electricity from renewables by 2030. So 50% of its energy consumption is from renewable energy. And to reduce the total projected carbon emission, this is one of the major one of the thing, the carbon emission by 1 billion tons through 2022 and 2030. So this is the another commitment has made by Indian government. By 2030, reduce the carbon intensity of its economy by less than 45% with respect to 2005. So on 2005 basis, so the India already made a commitment like for 2030, like 45% of carbon emission. I think this is also they made, I think. And also one more thing, most of the countries in world, they also made a commitment for net zero target. So India has committed for 2070, the India will reach the target for net zero in 2070. So these are the Indian climate related commitments given by our government. So now all of us and like all many researchers and the students and young minds, everybody is working about the same topic, how to reach these India related climate commitments. If you see in Delhi, if I am sitting in my room, so now the air quality is like 400, AQI is 400. So now it is not permissible to breathe. We don't know whether we are breathing pure air. It is completely, the environment is already polluted and we are taking that type of oxygen now. So now it is our responsibility. The same thing will also happen for other cities also, like in Hyderabad and West Bengal and Chennai also. So in Delhi, it is more, the intensity of this pollution is more. So now it is, people are now, it's not coming out of the rooms also, and we are also using like our refrigerator and washing machine and air conditions. We are also using air purifiers in our rooms also. In my room, I am using air purifier here. And now I am putting the air quality index is 50. So now then I may say I am breathing a purified air. So now we are not getting pure air also. So these are the congestions especially in Delhi. So it may be happen in other cities also in coming future. So that's why the India has already made a commitment. So these are the commitments, and all of us and all of engineers upcoming. This is the major research work everybody is working. And coming to that, the India is where in actions, where we are standing. So before going to the climate related commitments and before going to the scenario, and we should also think where we are standing and in actions where in India, which in actions, you can see India will leading a global recovery in energy demand. We are the third largest consumer of energy in the world. We are the third largest consumer of energy and fourth largest crude oil refineries. And like we are also fourth in the crude oil refineries and third largest crude oil consumer. We are also consuming most of the oil in the world. And the production as also and also import parameters I mentioned. And fourth largest LNG importer. So this is also one of the parameters we should also think about it. Fourth largest LNG importer. And we also, I mentioned here, the primary energy consumption to double by 2050 in all scenarios. So you can see the India Energy Command, that India evolving the primary energy mix. So I have mentioned here from 2021 to 2050 with respect to oil, with respect to gas, also I have presented here. Okay. This is from the KPMG resources. I got this one. And you see the India energy mission and target. So this is the roadmap. I can say the roadmap for India climate-related commitments. So by 2030, that is 500 giga non-fossil capacity, gigawatt non-fossil capacity, and 50% of its installed capacity from non-fossil fuel cells, and reducing the emission intensity of GDP to 45% below its 205, as I already discussed in my first slide. And coming to this 2047, we are also 2047 is energy independence, like 1947, our independence, and like 2047 is our energy independence will proposed. And 2070 is net zero target. So these are the Indian roadmap related to the climate commitments as given by our Honorable Minister, Prime Minister in many forums also. And see, not only India, in other countries like USA, China, Russia, Germany, Netherlands, France, Australia, Canada, and UK, more than 100 countries, they already committed for net zero target. So net zero target, I think India is committed for 2070, but Germany, I think they are committed 2045 because they are already working on EVs and non-fossil energy like green hydrogen technology. They are advanced with respect to other countries in the world. So that's why these are the net commitment, net zero targets for world. So we are also lagging like 2070, but China is 2060, 10 years ahead of our curve. Let's see. So when we will achieve. And now we see the pledges for what are the countries they made pledge. So you see like pledges for net energy consumption, net zero emissions, like it depends upon the mainly three parameters. One is 100% electrified sales, like including battery, plug-in hybrid electric vehicles, fuel cells, and hybrid EVs. So the pledge for net energy emission is like three parameters. One is 100% electric fuel sales, and another one is 100% zero emission vehicle sales, which includes the battery, plug-in, and hybrid fuel cells. And net zero pledge like carbon neutralization. This is one of the important. We need to go for what is the net zero pledge, what is the net zero target. So like carbon neutralization and no more greenhouse gases emissions. This is the, so like the countries, you can see, I have mentioned with the color code also, the China has already committed 100% electric sales field by 2035. Like Japan is also saying that 100% electric field sales by 2035. Like India is saying, in India, we can see here, India, they are saying that we are also committed, but 100% electric fuel sales, including battery and plug-in by 2070. Like we are committed like this. So these are the net pledge for the different countries, like from 2025 to 2070, like India and Canada and China, European, all these are the roadmap to achieve these pledge climate related commitments. Like these are the main issues, that 100% electric fuel sale, 100% net zero emission vehicle sale, and net zero pledge. So these are the three major parameters. They are mainly working for all countries. And coming to this, the world, just now we discussed about India. Come to the world is moving towards net zero with many countries already setting their targets. Not only India, the many countries already setting their targets. Like you can see, over 67% of global GDP is now covered by net zero target. So almost it's a 67% of the world is setting up their net zero target. And more than 100 countries in the world have committed to net zero carbon target by 2050. So, but India is committed by 2070, but almost more than 100 countries, they committed by 2050 the net zero target, net zero carbon target. And this is expected further increase by there is a conference by 2026. The COP conference will also held. So during that time, maybe they are giving some these climate-related commitments. So maybe it may be improved, and maybe it may increase by COP 2026 conference. And 56% of world top 250 companies acknowledges the risk of the climate changes in the financial report. Like in the world, they already witnessed and they already predicted there is some trust problem with related to climate risk, I think. So that's why the 56% of the world topmost 250 companies, they acknowledge the risk of the pollution and all related, the climate related changes. And more than USD 500 billions were globally invested decarbonization effect in 2020. But now we also started, the ministry has made so many programs to educate and for the research and reformation for these climate related commitments. The ministry in India also, they made so many changes. And because the first thing is we need to get more awareness about this green hydrogen technology and EV propulsion and what type of EVs are going in the market. So now they are already investing money for the first step. They need to educate the people, and then after that they may come for the real scenario. And like limiting to global warming to 1.5 degrees centigrade requires net CO2 emission to fall by 45% by 2030 and achieving net zero target by 2005. So if you make like 45% of this CO2 emission fall, so by 2050 only we are achieving instead of 2070. So this is the world is moving towards net zero with many countries already the setting. And coming to this, now let's see, we are electrical engineering and many of the researchers, they are started working on hybrid electric vehicles. Now you can see in the road, on the roads also, the electric vehicles already propelling now, like MG Motors. Now the key market is MG EV vehicle is the main key player is MG Motors and Tata Motors. They are the key market players in the EV industry. So like it is not a new concept. This electric vehicle concept is not only by 2020, but it has established in long back 1837. Like Scotland, it has started. It has built with a bigger car, the train related car. And after that, in 1884, you can see that the London also have made there is some vehicle that is after more than 40 years they introduced. And now you can see 1890, the USA also made like a 6-seater top speed of 14 kilometers per hour. So these are the history related to the electric vehicles. So it's not a new concept. It is already like 1890 onwards, the people are thinking and they are using. But now it is coming more intensity, like everybody, they witnessed about there is a need for the carbon reduction and net zero target according to our climate related commitments. So now it's the time to change and it's the time to renew the new technology, and we need to change our life skills. So we need to go with like EV related activities. And see, coming to that, I have proposed my presentation like this. So majority of EV related is the prime, for the propulsion of electric vehicle, the electric motor is one of the major component. Another one is batteries is another component. And like grid side converters and load side converters, these are another component. So here I am focusing on like motor, how the motor is one of the prime mover for the electric vehicle propulsion. So that I am considering here the various types of electric motors used in electric vehicle, like DC series motor, brushless DC motor, permanent magnetic synchronous motor, 3-phase AC induction motor. And these are first, whatever I proposed, these 3 motors like DC series motor, brushless, these are the first 4 motors is already, like if you see the Tesla 3S is now already, India also now they are manufacturing, they already started Tesla motors in India. By 2025, the Tesla vehicles also will propel on our Indian roads, I think. So they started in 2012. they started like induction motor, three-phase induction motor as one of the prime mover to propel the electric vehicle. But now later on they changed, because in induction motor, because of its rugged construction, they are using that induction motor. But they observed that because if you go for extended vehicle operation, extended driving operation, if one because of the overheat, if winding got burned, so then the entire journey will also disturb. So that's why they moved to some advanced motor technology with the research. So you can see here the flux reversal machine is also one of the component. So the main problem with this brushless DC motor, I'm going in detail. So like we know, we already studied like DC motors and induction motor, synchronous motor. I studied, and my students also studied, and my teachers and their teachers also studied about the conventional motors only. But now it is the time to grow, and it's the time to learn the new technologies like BLDC motor, PMSM motor, flux reversal motor, okay, and switch reluctance motor. I think linear induction machines are already there, but linear induction motors is not with the EV, but it is for electromotive trains application. EV, like linear induction motors also we can use. See, now what I can see, the DC motors, I think we know, everybody is aware of this DC motors. It is a highest starting torque, and it may be using for the like speed control. Maybe it is also initially the electric vehicle propulsion, this DC series motor they started using. But you know, the main drawback of DC series motor, it has a maintenance due to the brushes and commutator. So later on, this motor is maybe using by the Indian Railways, and like this, you can see here. So now DC series motor is now going with again on the brushless DC motor, brushless DC motor. So it is also called as a brushless. We can also call it as electronic commutator. We are using like a electronic commutator here. It is similar to DC motor with permanent magnets. We can say it is a permanent magnet DC motor. So there are two types of BLDC motors. We can say that one is like outrun type BLDC motor and in-run type BLDC. So what is this outrun type and what is this in-run type? Can you go more elaboration about this outrun type BLDC motor and in-run type? You see here this outrun type BLDC motor. So these are the like hub motors. We call it as this. This is mainly using for a bicycle application, like two-wheeler application. So we can say, so this is the wheel, I think. This is the two-wheeler. If you take, this is the wheel, I think. In this wheel, the rotor of the motor is present on the outside. So this rotor, this we call it as a rotor, and stator is inside here. And there is no gear and gear mechanism. Just you can plug and play. Your battery is charged, and then if you want to go, then you may start the vehicle. So this type of motor we call it as a hub motors, because the wheel is directly connected to the exterior motors. So like you can see here, so this was the hub motors, I think. And this motor makes a overall weight of this vehicle is less bulky. And to eliminate the space requirement, so mounting of the motor, the space requirement is also one of the major thing, and weight also we need to check. So the weight is also less, and it is also eliminating the space requirements for mounting the motor. This motor is widely preferred for electric cycles and manufacturing like Bulika and Troxoni and light speed vehicles. This we call it as a two-wheeler applications. So many of the two-wheeler applications we use to we will use this two-wheeler application by this hub type of motors. We call it as a outrun type BLDC motors. And come to this in-run type BLDC motor. So this type of motor of the this is like just reverse with the outrun, and this is in-run. What we call it as a the rotor is present in the inside. So inside it is like our conventional motors. Rotor is present inside and stator is present like as outside. Like this is the conventional motor only. So, but this requires some external transmission. The gear mechanism is required, but this will be like three-wheeler applications. Many of the three-wheeler applications like Goenka electric motors, like Kinetic Green. So these are the motors they are using for BLDC for three-wheeler application. So the main thing is it's low and medium performance, the manufacturers of BLDC for the propulsion. So here you can see, here I clearly mentioned the specifications of BLDC motor, like 48 volts to 96 volts and 10 kW. and the peak also 2 kilowatt and 3000 to 6000 RPM. And the dimensions I also mentioned, the dimension and length also. You see here in this side, here the gear mechanism. So this is also like three-wheeler applications we are using. The main drawback is costly because of the permanent magnets we are using. This is one of the major problem with this in-run type BLDC motor. You see, like in now metropolitan cities, like in Hyderabad also now these type of vehicles are available. We call it as e-rickshaws. So now in Delhi, most of the places you can see this, like diesel autos are not there. Now petrol autos are almost gone now. So now everybody is using this electric e-rickshaws now. And this cost of this e-rickshaws is around 1 lakh or 1,20,000. Like this is a 6-seater application. And here also they are using BLDC motor for the propulsion from one place to another place. But it is now coming to, I hope this technology will come to in all major cities in India. So that may reduce some pollution level, because now anyway we will not consume the diesel and petrol, and we may take like battery technology and it may propel for the application. See here, I have mentioned some dimensions here, number of wheels. Based on the literature which is available, the market is already, this type of vehicles are already available here. Motor voltage, motor type, the charger voltage, how much SMPS charger types are also using. And the maximum speed limit is like 25 kilometers per hour. Like our auto, if you take the petrol and diesel autos, they may go up to 35 to 40, but here it is only 25 kilometers per hour is the maximum case. The cost is around 1 lakh to 1,10,000, like that. And coming to that, for higher application, for four-wheeler application, for lorry, for transportation purpose also, now we are moving to the permanent magnetic synchronous motor, this PMSM motor. So there is another type of thing, we call it as a PMSM motor. So it is similar to this BLDC motor, which has permanent magnets on the rotor. The structure is same, but it is more rigid with respect to BLDC. And the difference is the PMSM has sinusoidal back EMF, whereas BLDC motor has a trapezoidal back EMF. This is important. So because the uniformity, the sinusoidal in nature, and there in the BLDC it is a trapezoidal in nature. But here also there are two types of PMSM motor. One we call it as a surface mounted PMSM, another one is interior or buried PMSM. So what is the difference between these two is, if you see here, in surface mounted PMSM, so this is the rotor. Okay, in this rotor, on the surface of the rotor, we are putting permanent magnets by using epoxy glue. We are pasting these permanent magnets on the surface of the rotor. But whereas in the interior or buried PMSM, so if you take like a rotor and there is some slot on the rotor, inside that slot we are putting as a permanent. That's why we call it as a interior or buried PMSM. For low speed application, the surface mounted PMSM motors are using. For higher speed applications like interior or buried PMSM motors are using. But these interior PMSM motors are more costlier than this surface mounted PMSM. If you see like our Tata Nexa car or MG car, they are using this interior or buried PMSM motor, and this is the structure of the permanent magnets how we are using. And you see this is the interior permanent magnetic synchronous motor. I cannot tell much about this because we are already teaching this particular course to the MTech students and BTech students. And now there is another mission. Now people are also started working on SRM motor, switch reluctance motor. So that is also similar to the PMSM motor. But what we will do in switch reluctance motor is there is no permanent magnets requirement. Once if there is no permanent magnetic requirement, the rare earth materials consumption is low. So then the cost will be less. But there will be one problem in SRM motor. So how to identify the initial position of the rotor? The initial identification of the position of the rotor is one of the major issue. So that's why the SRM motors also nowadays more popular in EV application. But the problem is the initial position identification. The rotor initial position identification is one problem. To overcome that, now there is a synchronous reluctance motor is also working. Now I am also working on this design of flux reversal machine. So this flux FRM is an invention type electric machine. So why this motor has more popular? The flux reversal machine, this Tesla is named it as some different name. They call it as a interior permanent magnetic synchronous reluctance motor. They name it as a interior permanent magnet. The same structure, but they changed some of the. I also changed some of the topologies. You see why this? Why people are working on this FRM motor is it has 4-quadrant operation. Forward motoring operation as well as braking operation is possible. Whereas your synchronous motor, like sorry, not synchronous, PMSM motor and your BLDC motor, it is a 2-quadrant trend. The magnetomotive forces versus flux, but SRM motor is only running in the first quadrant per positive. But here it can be operating in the 4-quadrant operation. So SRM is a unipolar magnetomotive force and phase flux, and to limit 1-quadrant torque only. But FRM is a bipolar magnetomotive force with flux variation with the rotor movement. So the flux variation with the rotor movement, and which enables the research. More research is possible in this. So that's why I may explain this principle of operation of FRM. You can see here, I'm visualizing here. You see, this is the pole shoe. We call it as this is the pole shoe. I'm considering here 2x3 pole FRM motor, like 2 poles on the stator and 3 rotor teeth. This is also rotor teeth. There is no winding on the rotor, just it's a like steel. We call it as a rotor teeth. Okay, the 3 rotor teeth. So these are the 3 rotor teeth and 2 poles. So like 2x3 FRM flux reversal motor. On the surface of the pole shoe, okay, we are putting like a permanent magnets here. So if you see like a holder, the pole shoe, we are putting some permanent magnets like a interior permanent magnetic synchronous motor. Here also we are making some in the pole shoe surface, we are placing 2 permanent magnets. They're opposite, like one is north pole, another one is south pole. In the bottom also, in the here also we are making here, this is the north pole and south pole. Coming to this, here I am enabling the 4 modes. This is the first case. So like rotor teeth is 50% of the north pole and 50% of the south pole. So then during that time, the zero flux position, this we call it as a zero flux position. And here there is no EMF. Okay. When I am changing from this position A to position B, I am rotating the rotor with 60 degrees in anti-clockwise direction. So when I'm rotating the rotor in 60 degrees anti-clockwise direction with respect to position A, what will happen is you can observe here. So in this case, so the rotor of the rotor teeth is now north pole is now symmetry. Here also you can see it is symmetry here. So now what will happen here is it makes the rotor to go to produce the torque, and it is a maximum torque we are getting. So this is the now at position B, when you make like 60 degrees from the first initial position, so then we are getting maximum torque here. And further, if I am making from this position, from position B to position C, further if I am making 60 degrees rotation, so then what is happening is it is also like a first position, like case A. So there also what is happening, north pole and south pole is now interacting. So it's neutralizing. So here also there is no zero flux linkages. So then this is position C also, there is no flux protection. So from position C to position D, if I'm making another 60 degrees of rotation in anti-clockwise direction, so then again my south pole is coincidence with my rotor. So here the south pole is coincidence. So then if the south pole is coincidence, if you can observe here the south poles of the both pole shoes are coincidence, so then it is again, it is a reverse direction, maximum torque is producing. So this is the magnetomotive force with respect to the rotation of the rotor position. So while observing this, this is also in a sinusoidal in nature we are getting here. And with this, what we can do, this is also one of the technology. Now people are working on this flux reversal motor, how to design like finite element analysis, like ANSYS software. These are the softwares, and now we are also moving for the development of hardware models also. And coming to what are the different types of electric vehicles which are already available in the market? There are different types of electric vehicles, majorly the 4 types of electric vehicles available in the market. like a battery electric vehicle, that is we called as a BEV. This is fully powered by the electricity, and there is no these type of the more efficient, compact compared to the hybrid and the plug-in hybrid electric vehicles. So this battery, just we need to take battery like lead, lithium ion batteries nowadays we are using. This is lithium ion batteries, and now we need to charge that battery, and then once we are going with the travel, so that charging that battery is giving power to the I will explain. So electric vehicles also, hybrid electric vehicles also two types. One is hybrid electric vehicle, another one is plug-in hybrid electric vehicle, and fourth one is like fuel cell vehicles. This is also nowadays it is coming popular. These fuel cell vehicles are like it is a green hydrogen fuel cells. Like we know, by using electrolysis process, so we can also produce this electrical energy, green hydrogen energy. So electric energy is produced from the chemical energy. For example, like green hydrogen fuel cells, it's one of the example. You see here, these are the different structures of the battery electric vehicles. These are the four, whatever I explained in the last slide, like battery operated electric vehicle, plug-in hybrid electric vehicle, and also fuel cell. So if you also see, by observing these pictures here, you can see here the battery is one of the key parameter in BEV, battery operated electric vehicles, and this battery is now the source of energy for electric motor, and then this electric motor will now move the propulsion. And here also you can see the plug-in hybrid electric vehicles, PHEV. So here it is like both the operation is possible. You can go with IC engine by using the fuel, and you also start working with the battery also. Like nowadays, the petrol and CNG combination is there. So like that, this is the plug-in. Now, plug-in hybrid electric vehicle is also more popular. In coming days, this plug-in hybrid electric vehicle is the one of the technology it will also leads in future. So now this plug-in hybrid electrical vehicle is a replacement of CNG plus petrol, and this hybrid electric vehicle is also there. Just the battery is also there. Just nowadays, this type of hybrid electric vehicle technology is already existing in the market from 2010 onwards. This type of Toyota or maybe Toyota car they are using. It is majorly it is running with the fuel only, like petrol only. It is running, but the battery is not charged from the external source. But whereas in the plug-in hybrid electric vehicle, the battery is also charged from the electric source. Like fuel cell, like we need to take like a hydrogen cylinder. We need to keep one hydrogen cylinder in the car, and then that hydrogen cylinder, whenever the hydrogen cylinder is empty, then again you need to refill it, and then you start. So this fuel hydrogen tank is also giving energy to the batteries like this. So you can also see more here in this case. So I have elaborated here like this BEV, 100% electric mode of operation, rechargeable batteries we are using, like 100% electric motor and fuel cell based. So this is the fuel cell based, and we are doing like hydrogen, and then it is going to the battery, and then it is moving the propulsion here, transmission system. This is like a hybrid electric vehicle. What we need to do in the hybrid electric vehicle, we are taking the oil like petrol or diesel. We will take this petrol, and this battery is not supplied from the external source. So battery is there, but it is now using for the interior applications, not for the extensively use. But whereas in the plug-in hybrid electric vehicles, you see here the difference between hybrid electric vehicles and plug-in hybrid electric vehicles. So both it is driven by propulsion is start by using like battery is charging by the electrical energy, and petrol is also now we can take that kind. Both IC engine plus battery, both will possible here. So these are the different topologies which are already available in the market. And now I have mentioned here the majorly the battery operated electric vehicle, like the companies you can see here, like MG ZS, Tata Nexon, Tata Tiago, Mahindra E20 Plus, and Hyundai. These are the major Tesla Model 3. These are the major companies. They are already manufacturing most of the vehicles. Like 80% of the electric vehicles now it is BEV, battery operated electric vehicles only. So because this battery you can charge from external source and then run the motor. And coming to this hybrid electric vehicle, like main components of hybrid, I mentioned here what is the main component, and This hybrid electric vehicle, it is like 2012 only. The Toyota Praise Hyundai, this company has started, and Toyota hybrid and the Honda Civic hybrid. These are the companies already introduced in 2012, but it is not giving much advantage compared to the battery operated electric vehicle. So now what they started, this battery is also now chargeable, rechargeable. Now you can see here, this is the plug-in hybrid electric vehicle. So now majority of the companies like BMW 330C and Nexa, most of the companies, Mercedes, almost all the companies, BMW i8, BMW X5, these are the companies, they are already started by using this plug-in hybrid electric vehicle. This is the best alternative in coming future. It may go either with the petrol and you also may go by with the battery. So both the things it is possible. And your battery is also started with the, your battery is also charged with the external supply. And see, this is the fuel tank, fuel cell electric vehicles. So this fuel cell is also like as a zero emission vehicle. We call it as a zero emission vehicle. And this is one of the best alternative in future also. The main components of EV like hydrogen storage tank. This is one of the major changes. Hydrogen here you need not produce any external energy also. But if you take like hydrogen cylinder, hydrogen storage tank, and then that storage tank will leads to a fuel cell. And then after that, that fuel cell is giving a supply to the battery. And then your battery is giving electrical energy to the motor and will start propulsing. So this is like, this is now the new technology. People are also working on this, how to store this hydrogen energy like tanks. Like if you see in our daily usage of in our kitchen, we are storing this gas. Okay, and then that gas now we are using for the burning purpose and for cooking purpose and all. So similarly, this type of fuel cells also we need to put as one hydrogen cylinder inside the vehicle, and that hydrogen cylinder will hydrogen tank will use as a fuel cell. Now we take as a fuel cell, and then you can start the vehicle. So this type of technology is also now people are working. Like comparison, what are the existing motors which are available in the market? So the comparison of the major motors in EV market, like I already told you, one is the brushless DC motor, another one is PMSM motor, another one is synchronous reluctance motor. So I already told you in BLDC motor and PMSM motor, both the rotor is made with the permanent magnets. But whereas in the synchronous reluctance motor, both rotor and stator is a steel material. And we are completely eliminating the permanent magnets in the synchronous reluctance mission. So that's why the major consumption, the components I mentioned, the first one is the permanent magnets is a major component of BLDC motor and PMSM motor. But whereas in the synchronous reluctance motor, the copper and steel consumes major cost, and magnets are not present. So this is one of the major advantage of the synchronous reluctance motor. That's why it is giving more interest on the synchronous reluctance motor application. So there is no permanent magnets. And you can see the noise level. One of the major problem with the synchronous reluctance motor is noise level is high. But noise level will be low. Noise level is low for the PMSM. So that's why it is giving higher priority. PMSM motors they are using for higher priority for EV propulsion is it has a low noise. And manufacturing cost is also high in case of PMSM motor. Now the research is going on synchronous reluctance motor, how to minimize the noise, how to reduce these cogging forces, cogging torque. Because one advantage is we are not taking any permanent magnets in the synchronous reluctance motor, and another disadvantage is it is producing more noise. So then how to minimize this noise level? So once you can reduce the noise level is only by producing the cogging forces the noise level is getting. So that's why we need to reduce this noise level. And efficiency, so the efficiency of the drive is low, and this PMSM motor, you can see here this PMSM, these are the reasons why the PMSM motor is giving more popular nowadays. But only the problem with the PMSM motor is efficiency, cost of the manufacturing is high. It requires permanent magnets. So that's why the cost of this PMSM is high, and the high speed applications like two-wheeler application, four-wheeler application, like storage vehicles, like transportation purpose also, like e-buses also we are using this PMSM motor. But low speed applications for low city applications like BLDC motors are using. And these synchronous reluctance motors are now in the developing state. Currently developing the technology is an alternative of PMSM motor to the country. It is increasing use in the magnets. Okay, so these are the comparison of the different motors are available in the EV. So before going to the in detail with this EV like PMSM motor or BLDC motor, we need to talk about permanent magnetic material properties. What are the different types of permanent magnets which are available on the market, and what is their merits and demerits, and how it may be useful. So there are majorly I mentioned here 5 magnetic materials, permanent magnetic materials. One is ceramic, another one is alnico, another one is samarium cobalt, niobium iron boron, and the injection molded. So okay, you can majorly we are concentrating on these first 4 methods like neodymium iron boron, samarium cobalt, alnico, and ceramic material. So if you talk about the real-time application, in Tata Nexa, if you see the in Tata Nexa, like PMSM motor they are using, like Tata Nexa motor is PMSM motor. There they are using the samarium cobalt or neodymium iron boron. So these two materials like samarium cobalt and neodymium iron boron, it has high magnetic strength property. But compared to these two, samarium cobalt and niobium iron boron, the samarium cobalt has highest Curie point temperature. So you know the Curie point temperature in the sense the temperature withstands the magnetic material. So it has like 420 degrees Curie point temperature is possible for samarium cobalt. Whereas this niobium iron, it has only 230 degrees of Curie point temperature. The magnetic property withstand ability we call it as a Curie point temperature. But some neodymium iron boron has less Curie point temperature, but more magnetic strength is possible. The BH curve loop with respect to field intensity and flux density plot, this neodymium iron is giving more flux density. So that's why I have mentioned here, you can see the advantages and disadvantages. So you can see the samarium cobalt, it has a high energy product. The pH curve we call it as energy product. So high energy product and temperature sustainability, high temperature sustainability, and the cost of this samarium cobalt is also high cost. That is one of the major problem. And we also neodymium iron boron. So neodymium iron boron is also very high energy product. We call it as a high energy product here. But here you can see here low mechanical strength and moderate temperature stability. Moderate is like 260 degrees temperature is a Curie point temperature. With respect to this samarium cobalt, this temperature is one of the drawback here. The costly also, it is a high costly. Okay, most of the we are not getting this. We are getting from China. The permanent magnets we are importing from China. That too, samarium cobalt we are importing. This neodymium iron boron storages are available in USA. And see the inventions in the motor technology to de-risk the supply chain. So here, my major intention to create this particular slide, to put this particular slide is, we are completely dependent upon the permanent magnets from China. So you can see here in this particular world map, I'm global production of share. Because see, in the like your BLDC motor or PMSM motor, the magnet cost is 53%. For example, if you take 100 rupees of a DC motor and 53 rupees is the permanent magnets cost, and remaining 47 rupees is the remaining, like these bearings, shaft, rotor iron, stator iron, insulation. This is what I'm, so most of the cost is decided by the permanent magnets in the propulsion of EV. So that's why the PMSM motors are more costlier than other motors existing in the market. So people are working. So how to neutralize, how to minimize, how to reduce this type of rare earth material. And like synchronous reluctance motor is also now one alternative, and another alternative is also called as a flux reversal machine. So that is also another, we are working on the flux reversal machine also. You can see here, I mentioned here the 53% is the magnetic magnets only, and we depend upon the China because highest storage, highest permanent magnetic material property stores are available from the China only. After that, I think Australia and South Korea, maybe we are India. We don't have such type of magnets in India. And see now the developments in the magnetless motor. This is also another point I need to highlight because the purpose of this workshop is also like green hydrogen technologies or propulsion of electric vehicle. So here, development of magnetless motor. This is one of the major challenge for all our electrical engineering faculty and students and those who are doing research, how to develop magnetless motor. So depending upon the rare earth materials can also reduce. If you develop this magnetless material, and we don't want to depend upon the rare earth materials. So that's why we are working on synchronous reluctance motor. Magnetless machine is synchronous reluctance motor suited for high speed applications due to its robust nature. So synchronous, the power density is one of the most important. The power density is also high for this synchronous reluctance motor, and the constant power reason and also fault tolerance is also good for the synchronous reluctance motor. The absence of the permanent magnets also eliminated. So that's why people are working on this synchronous reluctance motor. Reducing the dependency on rare earth materials. Currently, we are using BLDC and PMSM motor. Once, if you develop this type of magnetless motor, like synchronous reluctance motor, then obviously the reducing dependence on the rare earth materials like BLDC and PMSM motor. So there has been increased focus on developing the improved low-cost rare earth material, rare earth free magnetic material. This is likely to lead the lower manufacturing. This is one of the major problem for EV is, so the cost is decided by this electric vehicle. Electric motor is also one of the key parameter to design the cost of the EV. So that's why to reduce the manufacturing cost, so we need to go for rare earth materials also. Low cost rare earth material. If you go with low cost rare earth materials like Alnico and Alcomex and ceramic, but the temperature problem is there, and magnetic energy production that we call it as a magnetic field intensity is also less. So we are completely depending upon the samarium cobalt and neodymium iron for this BLDC motor as well as PMSM motor rotor construction. And you also see the motor controlling. The motor controlling is the responsibility for regulating the driving condition. So what are the major benefits of motor controller? So what are the, like, speed control is possible. Maintenance, constant speed is also one of the desire, and torque control to govern the motor torque, and electric vehicle protection, protection of the motor, subsequently the mechanism, and evaluating the mission performance and diagnosing the mission performance. And the unique feature of the motor control is like it is like a regenerative braking is also possible. So another advantage with this regenerative braking is also possible by using this EV type motors. And see the comparison of IC engine versus EV vehicle components. So you can see the IC engine like other equipments, chassis, vehicle body, and drive and transmission engine. So this is the composition of different parameters which are presently available in the IC engine vehicle. And now this EV vehicle, like battery packs is 35%, and like vehicle body is 10%. So okay, EV power transmission is 20%. You can see here the equipment and battery packs. These two things, like 55% is majorly depending upon the battery and also motor. Other equipment in the sense motor only, electric vehicle. So what I can say here, so 55% of EV, I told you this 30 and plus, this is like IC engine cost. These two things are the major thing. From 16% to, so like 16% is for this IC engine, and 55% we are going with electrical. So 55% is electrical. So 45% is similar to the IC engine, and 55% it is like battery and electric motor is changing. And 16% already, if you see here, IC engine, now already existing motors like your diesel or petrol engine, 16% is only electrical now. Electrical and electronic purpose is there, products are there. But now when you move from IC engine to EV, 55% now, almost like 40%, 35% we are now moving towards the electric vehicle component. And not only this, there is a battery management system is also there, and we need to go with the protection circuit model and advanced BMS technology. So if there is no advanced BMS technology, then automatically what will happen when you are giving electrical energy continuously, the batteries will also get excess power and it may possible to burn also. So that's why what we need to do is protection circuit model to advanced BMS technologies. So these are the evolution of BMSM. Like protective model, I told you here, protection circuit module. So this protection circuit module versus BMS, battery management system. So what is the advantage? How BMS can save the battery fires? This is one of the major issue. If you are not using this advanced battery management system, then definitely your battery may affect the firing. So that's why the over discharge protection we need to consider. These are the 6 parameters we need to work on the advanced BMS battery management system. One is short circuit protection, thermal runaway protection, cell balancing technology is one another case, and current protection, overcharging protection. See, now when we are charging our battery, so automatically if it is 100%, even though your plug is on, so then it is not taking the energy. So that's why your batteries, mobile cell phone batteries are not firing. So like that technology, we also adapt the same thing for the EV vehicle also. So overcharging protection also we need to enable. So that's why the BMS, we need to go with these are the emerging batteries chemistry. So advanced lithium ion, so lithium ion and lithium sulfate batteries, and now the market is also another thing is lithium ion batteries. So the lithium ion batteries also one of the major, we are also importing these lithium ion batteries from the other countries. So these all parameters will increase the cost of the EV. But now we are also like lithium ion, but lithium ion batteries production and lithium ion we are not importing, but we have enough storages in India. So that's why we are not depending upon the battery materials from other countries. That is one of the major advantage we are having this EV propulsion. And and also this advanced telemetric system also, IoT technology, because we need to check for the charging also. So advanced telemetric technology also is we need to inbuilt in the EV vehicles. And upcoming charging technologies like fast charging, hypercharging. So these are the wireless charging. Now, if you see the Sweden, they're already using this wireless technology, and payment option in the charging systems. So some of the charging, wireless charging systems is also now, India is also working on wireless charging systems now. And EV components industry growth by financial year 2025, like electric motors is 1.23 billions. So like this is one third of the key. Many of the manufacturers of electric motors, they are now coming with like BLDC motor manufacturing and PMSM motor manufacturing. And batteries is also 1.86 billions of now they are working. Like 67% will be the passengers car segment share in the batteries market in 2025. And power electronics like 1.47 billions, like 15.6 million kilowatt hour will be the total demand for lithium ion batteries pack in 2025. And charging stations also like 61% will be the 2-watt vehicle segments share in the power electronic market by 2025. And you can see here that I also did some comparison with electric vehicle with respect to petrol vehicle. So almost it is the cost I did like because battery is one of the major source of this EV. So there are 2 types of batteries I consider. One is lithium ion battery and lead acid battery. So these are the cost comparisons. So this lead acid battery is 35,000, but lithium ion batteries are 87,000. Almost is 90,000. But petrol is 60,000. You see per annum. If you take like per annum, so these are the things. But apart from the CO2 emission, so we need like CO2 emission is also one of the case. So the duration for 5 year wise, total running for 5 years. So if you take like if you are running with the vehicle for 5 years, like 75,000 kilometers, I have may considered for so many factors here. So the main point is the CO2 reduction by using the EV in 5 metric tons, like 1.9 metric ton by using lithium ion, but whereas the lead acid is 2.20, 2 percentage of metric ton, 2 metric ton with this. So, but we are not like carbon reduction is not possible with this petrol type. And we also like the EV adoption roadway in India. So now we have made like the ministry is already made certain rules and regulations for the EV propulsion in India, adoption in India. They are giving so many subsidies. So initially they make like National Electric Mobility Mission Plan in 2018. So that is NEMMP plan. And now they made, I think in 2021, they made like new proposal deadline for FAME in 2021. And now these are the central government has allotted 100 billions of EV subsidies under the FAM2 till 2024. So these are the some of the things like two-wheeler bus manufacturing and three-wheeler manufacturing and two-wheeler manufacturing share. So you can see here in 2024 only like buses I think 36 percentage, but four-wheeler I think only 6 percentage, and three-wheeler and two-wheeler I think 25 percentage and 20 percentage. Now after maybe they are giving more weightage for the four-wheeler application. Majority of our transportation is now moving with four-wheeler transportation only. So that's why now they are also thinking to give more subsidies for the four-wheeler applications. And now EV target for selected states. So like different state has different targets. Like I just compared from the literature, Delhi and Uttar Pradesh, Madhya Pradesh, Punjab, Gujarat, and Maharashtra, Andhra Pradesh, and Haryana, and Orissa, and Assam. So these are the different targets for the state governments. And these are the forecasted penetration curve for EV by I considered here like two-wheeler, three-wheeler, and buses, and four-wheeler, and the low electric vehicles also. I have trucks also. So like from 2021 onwards to financial year 2030, you see like almost by 2030, 90% like we will go with three-wheeler application, and 75% we will go with the scooters, two-wheeler application, and 37% we are using these buses, and like 15% you see here by the financial year 2030 there is only production is 15% of four-wheelers are possible. So this is about the challenges faced in the EV industry in India. So the battery charging infrastructure is one of the major challenge, and high price is another challenge, and also limited options with the lower mileage. So that is another problem. And dependency on the imports. I told you we are dependent upon the battery makers and high dependence upon the like lithium and other chemicals. Also, we are mainly import. We are depending on the import. These are the major challenges faced by India in EV industry like this. And this is about my today's lecture. So if you have any questions and other, please. Sharwan, I did my side. If they have any queries, they can please.
Okay, thank you, sir. Just a minute, sir. Participants from your sides? Okay, sir.
Yes, sir. Hello.
Now,
Yeah.
okay, sir, please.
Yes, yes, sir. Sir, mind blowing season, sir. Very informative season. Sir, my one question.
Yeah.
Yeah, and this which parts are for designing purpose in EV research? Which part also very informative and research help? And this in
You may use Maxwell's ANSYS, I think Maxwell's model.
okay, sir. Okay. Thank you, sir. Sir, if possible, this PPT also shared. Uh,
This PPT is not shareable because this is I am working on the same topic. Okay.
okay, sir. Okay.
Thank you.
Anybody apart from that? Okay, sir. Now, this session, vote of thanks will be given by Dr. S. Sivaganathan, sir. Professor, Polymer Institute of Technology.
Thank you, Saravanan sir.
Please, sir.
Good evening, everyone. It's a honor and privilege to deliver the vote of thanks at the conclusion of this impactful faculty development program on green hydrogen energy technology for EV applications. First and foremost, I extend our sincere gratitude to our esteemed speaker, Professor Dr. Chandrasekhar Ubi, for the enlightening session. Your insights into the evolving the role of electrical vehicle and its potential to revolution sustainable transportations have been involved. Your expertise have provided us with a deeper understanding and inspiration to incorporate this technology into our academics and research endurance. Finally, I extend my gratitude to everyone who contributed directly and indirectly to this program. Together, we have taken the significant steps forward in promoting sustainable energy solution for this future. Thank you. Have a wonderful day.
Thank you, sir.
With the permission, Sarvan, can I leave now?
Yes, sir. With pleasure. Thank you, sir.
Thank you. Thank you. Bye.
Thank you very much. Bye.
Dear participants, please fill the feedback form what we already posted in this group. Don't forget. Thank you. Have a grateful day. Tomorrow afternoon we'll post the next session information. Thank you. Thank you very much.
Thank you. Thank you. Thank you.
Thank you very much, sir.
Thank you very much.
Okay, Saravanan sir. Thank you, sir.
Okay, sir. Thank you. Thank you.
Thank
sir.
you,
Thank you.
Dr.
Thank you, sir.
Rambabu sir. Have a wonderful pleasure.
Sir.
Thank you very much for your support.
Yeah. Good night, sir.
Yeah, successful of this grand success of this FDB. Thank you very much, sir.
Okay. Okay, sir. Thank you so much, sir.
Thank you very much, sir. Karan sir,
So,
shall we
thank-
end this meeting?
Thank you all the participants.
Yes, sir. Yes, sir. Yes, sir. We can.
One
we
minute.
can.
HOD of EEE want to tell something. Rambabu sir, please tell.
Yes, sir. So thank you very much for all of you, all respected participants, being patiently listening the trends in the technology. Thank you so much for your encouraging. Thank you. Thank you all.
Rambabu sir, shall we wind up the meeting?
Sir, sure, sure, sir.
Okay, sir. Saravanan sir, with
Okay, sir. Okay,
okay,
sir.
sir.
Please.
Can I stop the recording?
Yes, sir.
Okay, sir. Thank you very much.
Thank you very
Thank
much.
you.